This problem dresses up like a puzzle with prefix maxes and a weird pairing ritual. Here's the surprise. It collapses into one loop, one sort, and 2 pointers walking toward each other. 15 lines done. Smallest with largest pairing shows up constantly in interviews at Amazon and Google. Real systems do the same thing when a scheduler matches the heaviest job with the lightest machine. Learn it once, and a whole family of problems opens up. Take each number and the biggest number seen up to that point and store their greatest common divisor. 426, for that gives 262. Then we sort it, pair the smallest with the largest, and add up the GCD of each pair. For tools, all friendly. GCD is the biggest number that divides both, like the largest tile that fits 2 walls perfectly. A running max is just the record holder so far, and 2 pointers means putting 1 finger on each end of sorted line. Think of a dance class pairing the shortest kid with the tallest so lines look even. Here's the trick. Once the array is sorted, smallest with largest is just index 0 paired with the last index, then index 1 with the second to last. In short, sorting turns the whole pairing ritual into 2 fingers walking toward each other. We keep one variable, mx, as the record holder and update it before computing each GCD. That order matters because the max must include the current number. We use Python's built-in GCD instead of writing our own because the standard library is faster and already debugged. Notice that when a number sets a new record, GCD of it with itself is just a number. We sort, then walk I up from the left and J down from the right, adding the GCD of each pair. The condition is I strictly less than J, and that's not an accident. When the length is odd, both fingers land on the middle element, and the loop just stops, ignoring it exactly like the problem wants. I once shipped the I less than or equal version and paired the middle element with itself. Friday deploy, never again. 4, 3, 6, 2, 8. The prefix array is the same numbers, since each new max mostly is the number itself. So do we get 2, 3, 6, 8. The outer pair gives GCD of 2 and 8, which is 2. The inner pair gives GCD of 3 and 6, which is 3. 2 plus 3 is 5, matching the expected answer. Pause the video and trace it by hand. Nums is just 2 and 2. What is the prefix array, and what comes back from the pairing? Commit to a number before the next slide. The max so far is 2 both times. So the prefix array is 2, 2. 1 pair, GCD of 2 and 2 is 2. Answer is 2. In short, duplicates don't break anything. Smallest and largest can be the same value. You could follow the problem word for word. Sort a list, then repeatedly remove the first and last elements and GCD them. Honestly, that's fine to say first in an interview. It's obviously correct and easy to explain. The catch is that removing from the front of a Python list shifts everything over, so it quietly becomes quadratic on big inputs. The 2-pointer version costs big O of n log n, and the sort dominates everything else. The pop from both ends simulation can degrade to big O of n squared, which hurts at 100,000 elements. Pick 2 pointers whenever n is large. The simulation is only for whiteboard warm-up. With 1 element, I and J start equal. The loop never runs, and we return 0. No special casing needed. Odd lengths skip the middle automatically, and values up to 1 billion are no problem, because GCD is logarithmic in the numbers, not linear. In short, the strict I less than J condition quietly handles every edge case for us. 1 pass builds prefixGcd with a running max. 1 sort lines everything up, and 2 pointers squeeze inward summing GCDS. The whole scary pairing ritual was just fingers on both ends of sorted list. New daily drops tomorrow, same time. Keep shipping. See you tomorrow.